Okay, hello everyone. So, what I'm going to do in this video is section 1.5, which focuses on equations. Now in the last video that I did, I don't know why, but for some reason, it did not upload the HD version of the video. I'm not sure why. Let me go ahead and just, okay. Okay, so I'm not sure why it didn't, but what matters is that, the only thing that matters is that you can see what I'm writing. I believe that it's readable enough. I'm not sure why, though, it did not upload the correct version, or the HD version, but it's okay. If there's a problem with that video, you can let me know, and like if you can't read what I'm writing, or if it just doesn't look good, I can redo it. But anyways, this is section 1.5, and it is about equations, okay? This is for precalculus. So, there are three kinds of equations that we're going to do. I mean, obviously this last part says other types of equations. Who knows? Maybe there'll be like, other types of equations, like with rationals and square roots and all that stuff. So let's look at, so basically, obviously they reteach you, and of course in precalculus you go over again like what each of these mean. The property A equals B. So if A equals B, then that means that A plus C equals B plus C, right? Anything you add to any to any variable, it's like if I say like x equals y, so therefore if I say plus z, then that means that x plus z will also equal y plus z, right? That's a property. That's an algebraic property. I'm not sure exactly what it is. I think it's, oh yeah, it's a property of equality. There we go. But this is the addition or subtraction property of equality. And also, basically if I say, so let's go ahead and do this really quick. So if x equals y, then x plus or minus z will equal y plus or minus z, right? That means that it will be x plus z will equal y plus z, or x minus z will equal y minus z, right? That's what it's saying, right? And that's the property of equality. And similarly, when you say a equals b, you can also say if x equals y, then a times, so ax will equal ay, because anything you multiply to x, you also multiply to the other side. And similarly, that's like if I say if 2 equals, or rather, I'm trying to think. If 3 equals 3, then 3 times 2 will equal 3 times 2, right? It's kind of like that, but I don't know how else to explain this, this property. So, and it's such that c does not equal 0. So basically, anything that you multiply that does not equal 0 will give you a equals b, right? And then we have a linear equation. These linear equations, of course, it's of the form ax plus b equals 0. You can also say mx plus b. it doesn't matter what you use as your a, or as your like, it doesn't matter if you use ax plus b, or, you know, as long as you use like, as long as you don't use like yx plus b, because that wouldn't make sense. But ax plus b, they usually use ax plus b or mx plus b. This is a linear equation, of course, and this is an example of a linear equation. So of course, a linear equation in example 1, we have 7x minus 4 equals 3x plus 8. So of course, to solve for x, you would subtract 3x on both sides. You would get 4x minus 4 equals 8, right? And then you would go ahead and add 4 to both sides, and you would get 4x equals 12. And then you would divide by 4 on both sides, and you would get x equals 3. That's just what that's saying. That's very simple. And yes, this is exactly what they're doing. And, you know, it's a little bit different than how I did it, but yes, at the end, they got x equals 3, right? And you also can check your equation, right? You can check by plugging 3 back in. You say 7 times 3 minus 4, is that equal to 3 times 3 plus 8, right? You would do 21 minus 4 equals 9 plus 8. 21 minus 4, if you do 21 minus 4, you get 17. And then 9 plus 8 is also 17. So yes, it is a solution, right? As long as the left-hand side equals the right-hand side. That's what LHS and RHS stand for. So as you can see, 17 equals 17, and that's how it works, right? And also, it says solving for one variable in terms of others. This is called a literal equation. So, for example, this is, of course, sometimes they would give you equations where it's a very special equation that you would learn either in physics or in like some other branch of, you know, of where you would learn a type of formula, right? It doesn't matter. At the end of the day, you don't have to know what Newton's law of gravity is, as long as you know how to manipulate what variable you're solving for, because that's what algebra is. You kind of, part of studying algebra is manipulating variables, right? And that's how it is for most of math, you know? You have to manipulate variables through calculus, through trig, through algebra, like all of those. You have to know how to manipulate variables. That's, you know, that's the part, that's a very important fundamental skill, right? So looking at this one, we have f equals g, and then it's like g, and then it's like an m and a big M over r squared, right? And we want to solve for this big M here, right? For this one, we want to solve for that. So to do that, we're gonna divide by g, right? On both sides. So we have f over g equals g, or rather, m over r squared, right? And then we would do times r squared on both sides. So we have r squared f over g equals little m times big M, right? And then we would go ahead and just divide by little m on both sides, right? And we would say r squared f over g divided by m equals big M. Now, you can simplify this, right? You can say r squared f over g times 1 over little m equals big M. So therefore, our big M is r squared f over g times little m, right? And this is what we got, right? Now this is another one. It says to solve. So this is obviously a geometric formula that you learned in geometry, right? And it's saying to solve for one variable in terms of others. So the surface area of a rectangular prism or rectangular box is shown in this figure here. And they just show it to you so that you can know exactly where it's coming from. You don't have to know like so much geometry for this, right? You just have to know how to manipulate so that you can solve for a variable. Now, it's asking us to solve for W, right? And you know, we want to solve for W. So if we look at this formula here, A equals 2L, it's 2LW plus 2WH plus 2LH, right? Now, what do you notice about this one? Obviously, we have a 2 in each term, right? So what does that mean? Using our algebra skills, we can divide by 2 on both sides, right? Because this is what we learned in algebra. A over 2 equals LW plus WH plus LH, right? And again, we want to solve for W, right? We want to solve for W. So what do? We're going to go ahead and subtract LH on both sides to get W, like to get our W's by themselves, right? To get it in terms of W. A over 2 minus LH over 1, that's like saying, so if we do cross multiplication, we get A minus 2LH over 2 equals LW plus WH, right? And then we go ahead and we factor W out. Now you can rewrite this. You can say LW plus WH equals A minus 2LH over 2, right? So then you can go ahead and factor W out. So you have W times L plus H equals A minus 2LH over 2, right? And you can divide both sides by L plus H. Now this looks hard, but you see this is kind of why they want to make sure that you know how to manipulate variables for the preparation of calculus. In calculus, when you do implicit differentiation, you're really going to have to know how to manipulate variables. So this is kind of why we're doing this here, right? So then we have W equals, and we can do a division of two fractions, right? A minus 2LH over 2 divided by L plus H. So then we use dividing fractions rule where we have A over B divided by C over D equals A over B times D over C. So basically, yeah. And we have A minus 2LH over 2. And then we're going to go ahead and change this to multiplication. And we're going to put this all over 1 over L plus H, right? So then we have A minus 2LH over 2 times L plus H. Now, this simplifies as A minus 2LH over 2L plus 2H. So this is our final answer. So as you can see over here, this is exactly what they got, right? Okay, now a quadratic equation. Again, a quadratic equation. We did these in college algebra. When we went over college algebra, we learned about what a quadratic equation is. Now there's so basically it says a quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers with a does not equal 0. The reason why they say a does not equal 0 is because if we have 0x squared plus 1x plus 1, for example, it will not be a quadratic. It will be a linear equation, right? And then it says some quadratic equations can be solved by factoring and using the following basic property of real numbers. So there's this part that says zero product property. Obviously, we learned about zero product property. So basically, a, b equals 0 if and only if a equals 0 or b equals 0. So basically, that is kind of like if I say, like, and if I say a equals 2, b equals 0, then that means that 2 times 0 equals 0, right? But what if I said, oh, ab equals 0, if a equals 0, but b equals 2, right? I would say 0 times 2, that's just 0. So what if I made it ab equals 0, if a equals 2 and b equals 2, right? I would say 2 times 2 equals 0, 4 equals 0. That's not a true statement. That's why the zero product property is very important here. Because if these two are factors, like x minus c, and this is like x minus d, then x equals c or x equals d. That's what it's saying. Let's see here. Okay, so then it says solve a quadratic equation by factoring. So obviously, they want to make sure that you are well equipped for calculus. Now we're going to try to solve this, and again, like, you can use your Xbox and your square method. That's okay. It would be great though if you learned how to do it with, by just doing it in your head, because basically you just ask yourself, well, you subtract 24 on both sides, right? And it would be equal to 0, and then you would say, well, what are two numbers? So if a times c, that's negative 24, and then you have 5, right? What are two numbers that multiply to negative 24 and add to 5? That would just be, so let's think about this one. It would be, negative 3 and 8, right? So then you would say x minus 3 times x plus 8 equals 0. Now, I could have done it without the Xbox, right? I would say, okay, what are two numbers that add to 5 and multiply to negative 24? Well, I would say x, and I would say x minus, it would be x minus 8, or no, x plus 8 times x minus 3, right? So you see how it's kind of, this was done with me having to actually think about it. It is possible to train your brain to think about it without doing the Xbox, as long as your x squared has a leading coefficient of 1, meaning that a equals 1, right? So as you can see, the solutions are x equals 3 and x equals negative 8. So, obviously, this is just saying, so it's saying that if we have a quadratic equation of the form, so x squared equals c, where c does not equal 0, then x will equal plus or minus the square root of c. This is what we learned when we did quadratic equations by square root method. So it's like if I said x squared minus 1 equals, for example, x squared minus 1 equals 2, you would add 1 on both sides, and you would say x squared equals 3. And then you take the square root, so then you have to say x equals plus or minus the square root of 3, meaning that x equals square root 3 and x equals negative square root 3, right? And they factored it, but they factored it in the way that they said, well, you know, it would be like, of course, if we had x plus the square root of 3 equals 0, and x minus square root of 3 equals 0, right? They factored it like this. That's why over here you see x minus square root c times x plus square root c equals 0. And the solutions are x equals square root c and x equals negative square root c. And then it says we often abbreviate this as plus or minus square root c, right? So obviously, in college or in pre-calculus, you go over these again, right? You would, for example, the first one says x squared equals 5, right? Now, I mean, obviously, like I said, when you have a quadratic where you have to solve, if you have a quadratic where it's of the form x squared minus c equals 0, it's okay to add the constant to the other side. That way you can just take the square root and you can just say x equals plus or minus square root 5. So x equals square root 5 and x equals negative square root 5, right? And similarly, when you have something like this, x minus 4 quantity squared equals 5, you would have x minus 4 equals positive or negative or plus or minus square root 5. So therefore, your answer, you would add 4 on both sides, get x equals 4 plus or minus square root 5. So your answers are x equals 4 plus square root 5 and x equals 4 minus square root 5. That's just how it is, right? So you see right here. Okay, and then we do the completing the square, right? This is another thing that we did in college algebra, where solving a quadratic by completing the square. Now, x squared minus 8x plus 13 equals 0. What we did was we said, well, there's a minus 13 on both sides, right? And then we said x squared minus 8x. And then we said plus a third term c is going to equal, and whatever third term c we want to make it to, because we want to make this a perfect square trinomial, we're going to go ahead and add that c to the other side as well. So then we have this formula that says that c equals b over 2 squared, quantity squared, where y equals ax squared plus bx plus c, right? So here a equals 1, b equals negative 8, and we want to know what c is, right? Well, c is going to be the quantity negative 8 divided by 2, quantity squared. And then we're going to say, well, this is just equal to negative 4 quantity squared, which equals 16. So then we have x squared minus 8x plus 16 equals negative 13 plus 16, right? And then we have, this is a perfect square trinomial. If you factor it, you get 1 times 16, right? You get negative 8. And then you have two numbers that multiply to 16 and add to negative 8 are negative 4 and negative 4. So then you would say x minus 4 times x minus 4 equals 3, right? And then you would say x minus 4. You can turn this into a square term, right? Quantity squared equals 3. So then you take the square root of both sides and you say that x minus 4 equals plus or minus the square root of 3. and then you go ahead and add 4 on both sides, and you get x equals 4 plus or minus square root of 3. So your answers are 4 plus square root 3 and 4 minus square root 3. Right. So you see here how they did it. And then similarly, you can do that for the other equation here. You can say, well, this is, okay, so let me go ahead and do this one. 3x squared minus 12x plus 6 equals 0. And I think, okay, so this one you can do, so you have 2 ways to do this. You can divide by 3 on both sides, and then you can say, well, this is x squared minus 4x plus 2 equals 0. And then you can say, well, minus 2, you can subtract 2 on both sides, you have x squared minus 4x. You're going to add a c term is equal to negative 2 plus c. Now you have to solve for c. C equals b over 2 quantity squared, where b is equal to negative 4, so you have c equals negative 4 over 2 quantity squared. You have c equals negative 2 quantity squared, c equals 4, right? So then you have x squared minus 4x plus 4 equals negative 2 plus 4. So then you would say, you would factor this. This is 4 and then negative 4. So 2 numbers that multiply to 4 and add to negative 4 are negative 2 and negative 2, right? So you would say x minus 2 quantity squared equals 2. Then you would take the square root of both sides. You would say x minus 2 equals plus or minus square root 2. And then you would go ahead and add 2 on both sides. You would say x equals 2 plus or minus square root of 2. So your solutions are x equals 2 plus square root 2 and x equals 2 minus square root 2. Okay, I'm going over this very fast because this is review. If you want to know more about like how to actually do this, I do have a on my algebra playlist. I do have a whole playlist of how to do these things. And this is just like, you know, this is a proof of the quadratic formula. This is another way that they do it. Of course, in algebra, you can solve any equation by using either completing the square or the quadratic formula. Now, the quadratic formula is probably the best one that you can actually do. Because, or no, it actually is, because it says the quadratic formula could be used to solve the equations and examples 4 and 6. And this is the one that they use for when they kind of, you know, when they actually, it's kind of like your last resort if you don't know how to solve it using factoring, or if you don't know how to solve it using, you know, completing the square. You can always use the quadratic formula. And now the quadratic formula, and I'm going to go over this one very quickly. 3x squared minus 5x minus 1 equals 0. You would do, so it's going to be negative of negative 5 plus or minus the square root of the quantity negative 5 quantity squared minus 4 times 3 times negative 1 all over 2 times 3. How did I know that? Because the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you have this memorized, that is perfect, because that is just great, because this, I mean, you can use this in calculus as well. Like when you're solving a, like when you're doing the what is it called? The critical points of a polynomial, and you have to solve a quadratic for 0. You can use the quadratic formula. And also when you're doing the, oh, there was one more, the inflection points, and you're solving for the second derivative, you're solving the second derivative for 0, you can use a quadratic formula. That is if your second derivative is a quadratic function. So doing this, you have 5 plus or minus the square root of 25 minus 12 times -1 all over 6. And then you have 5 plus or minus the square root of 25 plus 12 all over 6. And then this will give you 5 plus or minus the square root of 37 all over 6. So that means that x equals 5 plus square root of 37 all over 6. And then, or x equals 5 minus square root of 37 all over 6. That's how it works. And so as you can see, this is how it is. This is just another example, and this is another example, but that's just how it works with using the quadratic formula, right? I'm trying to go as fast as I can in this section. And the discriminant says, well, the discriminant says that you can find the number of solutions to a quadratic. So for example, if I have x squared plus 2x plus 2 equals 0, and I want to say find how many solutions, how many real solutions this quadratic has, right? Now what I mean by real solutions is no imaginaries, no negative square roots, etc. Like in the quadratic formula, right, you have, they say if b squared minus 4ac, oops, equals 0, then there is one solution. Right? That's like if I said 2 or -2 plus or minus square root of 0 over 2 times 1. I'm like, okay, well there's -2 plus or minus square root of 0 over 2, right? And then I'm like, okay, this is -2 over 2. So that's if my, if I do a, b, and c, if I plug a, b, and c in for this, and I get that b squared minus 4ac is equal to 0, then that means I'm only going to have -b over 2a, really, as my answer. Right? X equals -b over 2a. Now, if they say if, so let me just go ahead and like explain how they're doing this. So let's see here. So on the first one, they're saying that the discriminant, which is b squared minus 4ac, and I went over this in my college algebra playlist, so that's kind of why I'm going over this really quickly. I'm going over this extremely quickly. So if we do b squared minus 4ac for this one, we have -4 squared minus 4 times 1 times -1. I get 16 minus 4 times -1. This is 16 plus 4, which is 20. So because the discriminant is greater than 0, there will be 2 real solutions. That's because the square root of 20 is plus or minus, what is it? It's 2 square root 5, right? Yes. Plus or minus 2 square root 5. So, and if you don't know anything about the discriminant, I do have a video in my algebra playlist that you can look at, or in my YouTube channel that you can look at. Okay, this one, now they're modeling using a quadratic equation, right? So it says an object is thrown or fired straight upward with an initial speed of v0 feet per second, where, or rather, hold on. It says of v0 feet per second will reach a height of h feet after t seconds, where h and t are related by the formula. H equals negative 16t squared plus v0 t. Suppose that a bullet is shot straight upward with an initial speed of 800 feet per second. Its path is shown in figure 2. So, I mean, I know that I don't know if I went over quadratic application problems in my college algebra playlist, or in my college algebra videos, but we can do this one very quickly, right? So now it says part A, right? We have h equals negative 16t squared plus v0 t. Now it always helps to label what each variable means, right? It says h, so h is defined as the height in feet, right? And then it says that t is equal to the time in seconds, right? So, and then it says that v0, the reason why I say v0 is because this is a little zero. That's what we call this little, like, zero symbol, v0. It's like the word not, you know, but it's v0. They just call it that in physics for some reason. V0 is the initial speed, right? V0, or you can also say v sub 0, but they call it v0. This is the initial speed, right? In feet per second, right? And they want to know, when does the bullet fall back to ground level, right? It says, suppose that a bullet is shot straight upward with an initial speed of 800 feet per second, right? So that means that the initial speed, v0, is 800 feet per second. So that means that we are going to have the function h equals negative 16t squared, or the height will equal negative 16t squared plus 800t. You can also say h of t, since this is literally looking at this as a function of t in terms of h. So the height is h of t, where h is the dependent variable and t and time is the independent variable, right? And it's saying, when does the bullet fall back to ground level? So if you think about it, that means that when it's talking about ground level, that means that its height is 0, okay? So look, if you think about this function, this is a parabola going like this, right? It's downwards because a is less than 0. Remember when I said that if we have, so basically y equals ax squared, if a is less than 0, we were going to have a graph like this. So that's what this is. And it's saying, when does the bullet fall back to ground level? So when it's saying when, it wants us to solve for the time, right? That means that the height is going to be 0. So if we set this equal to 0, we can solve for t by dividing by -16 on both sides. You can also do by 16 on both sides, but anytime you have a negative in the front of your a term, right? You can, like, I would recommend that you just automatically what is it called? Divide by the negative number to make the equation positive, so that way you don't mess up your values, or you don't have to work with negatives, right? So if we do 800 divided by -16, that'll be -50. So in reality, this will be 0 equals t squared minus 50t, right? So then solving for t, we're going to get, we can solve this by factoring, right? We're going to get 0 equals t times the quantity t minus 50, right? Because remember when I said x squared minus 2x equals 0, we can factor out the x. X times x minus 2 equals 0. And then we can use the zero product property. This is saying that t equals 0 or t minus 50 equals 0, right? So that means that t equals 0 or t equals 50 because we add 50 to both sides, right? So that means that the bullet will fall back to the ground at t equals 0 seconds and t equals 50 seconds, right? And then it's saying, when does it reach a height of 6,400 feet? So that means that we have to make, so again, using our function, we have 16, or rather, -16t squared plus 800t right? And we have, when does it reach a height of 400 feet? So that means that we have to set h equal to 400, or 6,400, excuse me. So 6,400 is equal to -16t squared plus 800t. Now, be very careful. Do not set this, so do not factor the t out of this and then set it equal to this. It is not going to be correct. You always, anytime you have like x squared plus, I don't know, like 2x equals c, you always want to make it equal to 0. Every single quadratic equation that you do, unless you want to solve it by completing the square, that's fine, because you do this by completing the square, and then you can try to do that, but you also have to have a third term here eventually, and you have to do the perfect square trinomial, etc. So, I mean, in reality, I would just do this, right? Set it equal to 0, and then you have 16t squared plus 800t minus 6,400 equals 0. And you can divide all of this by 16. It's okay to do that, because that makes your equation a lot easier to solve when you're doing when you're doing, what is it called? When you're dealing with big numbers. So, since we already know what 800 divided by 16 is, so it would be 0 equals t squared plus, it would be t squared, or actually, oh yeah, and then this is negative, right? So it's 0 equals negative t squared plus, or actually minus 50 or actually no, it would be plus 50 because we would have this, right? And then because we were dealing with a negative, right? And then it would be plus 800t and then minus 6400 divided by 16. That is minus 400. Now you can go ahead, and if you don't like working with a negative in the front of your variable or whatever, you can divide this by negative 1. And if you don't know how to work this out, it's okay. You can just say that this is negative the quantity t squared minus 50t minus, or actually plus 400, right? Over negative 1. This will cancel out. So you have 0 equals t squared minus 50t plus 400. And you can solve using the, what is it called? Completing the square, or you can solve using quadratic formula, whatever you want to do. Or you can even use the X box. 8 times c is 400. You have negative 50, so two numbers that multiply to 400 and add to negative 50. Let me think about that one. So honestly, actually, you know what? So, give me a second, hold on. Okay, so for this one, if you want to save time, I would just use the quadratic formula. Negative of negative 50 plus or minus the square root of negative 50 quantity squared minus 4 times 1 times 400 all over 2 times 1. You can use factoring if you can. I mean, you can try to do that. Yes, you can try to do that. But just know that it'll take you a little bit longer, because in reality, like, I mean, yes, you can go ahead and do that. I mean, we could have just said, like, you know, t minus 40 times t minus 10. However, if you don't know how to factor, like, if you don't know two numbers that multiply to 400 and add to negative 50, just know that when you do the tree, it's going to take a little longer. Right? So doing it that way, like so basically doing it this way, is going to take a little longer to do. So yes, doing it this way will take a little longer to do, because, you know, you're going to have to do the X box, etc. So I would really recommend that you guys memorize this formula here. I know they also did like a whole song for it. I didn't memorize it using the song. I just memorized it on my own. It wasn't hard for me to memorize because I think I saw it so many times, and it just, you know, I became like, what is it called? you know, I became accustomed to it. So, but if you want to memorize it, I would highly recommend that you memorize this, because this formula here will save you so much time when you're solving quadratics. So yes, I mean, you can do it this way. T minus 40 equals 0, t minus 10. Oh god. Equals 0, and then you say t equals 40, t equals 10. So at 40 seconds and 10 seconds, the height is 0 feet. That's how you would put your answer in terms of the application. So the bullet, or actually you would say, hold on, my bad, hold on. The bullet, so you would say, in terms of the application, you would say the bullet reaches 6,400 feet at t equals 40 seconds and t equals 10 seconds, right? So sometimes the professor, the teacher, wants you to like put your answer in terms of the application. You don't want to stop here, because then I know that there are some people that just stop here and then they're like, okay, well that's it. T equals 10, t equals 40, I'm done. But no, you have to, because this is a what is it called? The real question is this. It is not just an equation. You're setting up the equation, but you're not, you want to make sure that you answer it in terms of the question. So I would say, like, you know, the bullet reaches a height of 6,400 feet at t equals 0 seconds and t equals 10 seconds, or whatever. T equals 10 seconds and t equals 40 seconds. Like, I would do it that way, because that way, you know, that would be very, the professor would say, okay, well, yes, you know, they answered it in terms of the application, so they do get a point, right? What does the third one say? When does it reach a height of 2 miles? Okay. Now, I mean, they would have to give you how many 2 miles, how much is a mile in feet, and then you would just do the exact same thing you did on the first one, or on part B, and then do it on part C. And what does part D say? How high is the highest point that the bullet reaches? Now, this one's interesting. This one is one that I believe, I don't know if I went over this in a previous, but like, we have the function negative 16t squared plus 800t. Oh god. And it wants to know, now obviously if you do graph this, or if you use a calculator, right? Now let's say you can't use a calculator for this. You would have to remember that this function represents an upside down parabola. You can do like a little sketch like this. Now when it's saying, the question is asking, you have to really pay attention and read very carefully what the question is asking. It's saying, how high is the highest point that the bullet reaches? So what they want to know is, like, what is the maximum point, or because this is h and then this is the time t. So what is the maximum height, basically, what is the maximum height that this here reaches? Now, there's a way to do this. So this is exactly like when we did the vertex of a parabola, where if we have like x squared minus 2x plus 1 equals y, right? And we look for the axis of symmetry and we do like something like this, and it's like negative of negative 1 over 1, and then it's like obviously positive 1, so then it would be like, oh, f of 1 is 1 squared minus 2 times 1 plus 1, so then we did 1 minus 2 plus 1, f of 1 is 0. So that's what this is saying. They want you to find the, so it's saying what is the maximum height. How you're going to do this is you're going to go ahead and, so basically, oh lord. So you can rewrite this, right? You can rewrite this, and if we have h of t is equal to negative 16t squared plus 800t, I mean, I would say t, like, I would say, like, what is it called? Either way, if you divide by negative 16, it'll still give you, or negative 16t, it'll still give you the same vertex. But this one, you would say, like, h of t is equal to t squared. And then it would be, like, or no, it would be, oh my goodness, give me 1 second, guys. My bad, it would not be negative 16t. It would be negative 16, because you want to make it sure that it's very simplified, because who would want to do, like, because obviously this is of the form ax squared plus bx plus c, and then where b is, like, negative 800 or positive 800, right? And then, a is negative 16, so it would be, like, 800 over 2 times negative 16, and it's just really big numbers, so you don't want to do that. That's why I recommend that you divide by negative 16, so that way you have t squared, not negative 16t, because that's if you're factoring. You want to do negative 16, so that way you can go ahead and say that basically, you can find your vertex more easily, right? So 800 divided by negative 16 is negative 50, right? And obviously, our axis of symmetry is x equals negative b over 2a. This is of the form at squared minus bt plus c. So basically, or plus bt plus c. So basically, t, or actually b, equals negative 50. So then you would say x equals negative 50 over 2, or negative of negative 50. Because if you think about it, right? So then, this would be negative 50, and you would say x equals negative of the quantity negative 50 over 2 times, what is it, 1? Because a is 1. So then you would say negative of negative 50, that's 50 over 2. So it's 25, right? And then you would say, well, and I am sure they would let you use a calculator for this one, because, I mean, like, I really doubt they wouldn't. In reality, these questions need to be answered in terms of the application. So even if you do get the answers with the calculator, you cannot just say, oh, that means that the maximum is this, and you have to put it in terms of the application. So x equals 25, and then you would plug that back in for t. So in reality, t equals 25, so you would say 25 squared minus 50 times 25 is equal to your vertex, or your y value of your vertex. So you would use your calculator. 25 squared minus 50 times 25, that would be negative 625, right? So then you would have your vertex would be 25 comma negative 625. And now in terms of the problem, it's asking oh god, what was it asking? Give me a second, guys. Okay, this last one's interesting. I mean, I had thought that they were doing it in a different way. It looks like what they did was they found the discriminant of the equation. I am so sorry, guys, by the way. I did not know they were solving it this way. They went ahead and they solved for the discriminant, and they got h equals 10,000. So the discriminant is 0, and then they went ahead and they just went ahead and solved for h. Okay, let's move on. Let's move on, because I I think we've had enough of looking at quadratics. It says other types of equations. So it says an equation involving fractional expressions. We have this equation here, 3 over x minus 2 over x minus 3 equals negative 12 over x squared minus 9, right? Now let's very quickly read what it says. So far we have learned how to solve linear and quadratic equations. Now we study other types of equations, including those that involve higher powers, fractional expressions, and radicals. When we solve an equation that involves fractional expressions or radicals, we must be especially careful to check our final answers. The next two examples demonstrate why. So this is exactly what I was, obviously we've been over these with, I think I briefly went over this with college algebra, but here we want to solve for x, right? And I mean, honestly, if you want to try and subtract this out, you can. It might take you a little longer to do this problem, but I mean, if you want to do it that way, go ahead. But honestly, I would look at this. So looking at this expression here, right? Obviously, we want to make it so that these two are equal to this, right? How are we going to do that? Because we want the same denominator in reality. Okay, so if you look at this, so, I mean, if you really don't know how to, manipulate this so that you can make the left side look like this, I mean, you can go ahead and subtract this out. So if you do that, you have 3 times x minus 3. You can do cross multiplication. And then minus 2 times x all over x times x minus 3, right? This is all equal to 12, or negative 12 over x squared minus 9. And then you would have, so, I mean, honestly, but there's also some, how do I say it? There's also some, actually, I take it back. Doing that actually makes it more complicated. Because if you do that, you're going to end up with a polynomial at the end, and then you're going to have to do, like, the fundamental theorem of algebra and doing all that stuff, and it's just going to be so unnecessary. So in reality, I mean, how do we solve this, right? The one thing that basically can happen, we can make this, so we want to look at this first, right? Let's look at this part first. 3 over x. We want to make it so that it looks similar to the denominator of this, right? So doing that, we're gonna go ahead and do times x minus, or not x minus 3, but okay, actually, you know what? Let me go ahead and do it. Let me just try to see really quickly. 3 over x minus 2, because this one's a little tricky. I'm gonna be honest with you guys. So if we do the rule, so if we do this rule, a over b minus c over d equals ad minus bc over bd. If we do that rule, we're going to go ahead and get this, so minus 2 times x over x times x minus 3 equals negative 12 over x squared minus 9. And then we have 3x minus 9 minus 2x over x times x minus 3 equals negative 12 over x minus 3 times x plus 3, because this we can factor out. We can factor, right? So then we have x minus 9 over x times x minus 3, because 3x minus 2x is x, and then negative 9 is negative 9, equals negative 12 over x minus 3 times x plus 3. And then we have negative 12 times x minus 3 equals x minus 9 times x minus 3 times x plus 3. Okay. So we can do this way, right? And then we can go ahead and divide by x minus 3 on both sides. Cancel this out. Negative 12x equals, cancel this out here, x minus 9 times x plus 3. And then we can go ahead and do plus 12x on both sides. This is 0 equals x minus 9 times x plus 3 plus 12x. This is equal to 0 is equal to x squared plus 3x minus 9x minus 27 plus 12x. So then we have 0 equals x squared plus 3x plus 12x minus 9x minus 27. This is equal to 0 equals 2x squared, and then plus 15x, that's what this gives us, minus 9x minus 27. Then we have 0 equals x squared plus 6x minus 27. And then we can use factoring to solve for this, right? So two numbers, or hold on, our a times c term is negative 27, right? B is 6. This is our b term. Two numbers that multiply to negative 27 and add to 6 are negative 3 and 9, and that's because negative 3 plus 9 equals 6. Negative 3 times 9 equals negative 27. So then we have 0 equals x minus 3 times x plus 9. And then we have x minus 3 equals 0, or x plus 9 equals 0. We solve those two linear equations for x. We get x equals 3, and then x equals negative 9, right? I did that very fast because... So, I did that very fast for a reason. I did not want to spend a lot of time doing or trying to explain how this is done, because obviously I believe I did a similar one to this in college algebra. So like I said, in this class it's very fast-paced. Everything that we did is very fast-paced, and college algebra is very fast-paced, so that's why I'm going over it extremely fast. So then we check our solutions, right? We want to check our solutions. We have 3 over x minus 2 over x minus 3, so is equal to negative 12 over x squared minus 9. Now, you have to be careful when checking this, because if you check x equals 3, anytime, so hold on, the 3 over 3, is that what it said? 3 over x? Okay, 3 over 3 minus 2 over 3 minus 3, is that equal to negative 12 over 3 squared minus 9? 1 minus 2 over 0 equals negative 12 over 9 minus 9. This is 1 minus 2 over 0 equals negative 12 over 0. So how would I make that a true statement? So basically, if I have 1 over 1, and I say, oh, 1 times 0 minus 2 times 1 over 0 equals negative 12 over 0. That means that, so basically, this is not a true statement. And let me go ahead and try to check it very quickly. Okay, so regardless, even if this is a true, so what I'm trying to say is, anytime you get undefined, anywhere, if you get undefined, it's not a solution, period. Like, it's not gonna satisfy the equation. So x equals 3 is an extraneous solution. Now if we do negative 9, 3 over negative 9 minus 2 over negative 9 minus 3 equals negative 12 over 9 squared minus 9, right? This is equal to negative 3/9 minus 2 over negative 12 equals negative 12 over 81 minus 9, which is equal to, so negative 3 over 9, that's negative 1/3 minus 1/6 equals negative 12 over what is this, 72? So this simplified is going to be negative 1/6. So then or wait, excuse me, my bad. This is, oh my goodness. So when we do, it's a plus negative 2 over negative 12. At least I think. Give me 1 second, guys. Hold on. Okay, so this is equal to, so negative 3/9, and then we have minus, and we're going to put this in parentheses. It's going to be negative 2 over 12 equals negative 12 over 81 minus 9. So then we have, this is negative 3/9 plus 2 over 12 equals negative 12 over 81 minus 9. 81 minus 9 is, oh my god, what is it? It's, 72? Yes, and then, we simplify this. This is negative 1/3 plus, and then this is 1/6. So then we have, and then negative 12 over 72, that's negative 1/6, I think. So then this is gonna be, so if we do like, basically like this, we have negative 6 plus 3 over 18 equals negative 1/6. So then we have negative 3 over 18 equals negative 1/6. So then that means if we do cross multiplication, negative 3 times 6 equals 18 times negative 1. So then negative 18 equals negative 18. So then we checked our solution, and this is a real solution. So that means that our solution is x equals 3. Okay, I know that took a little bit longer than usual. So you see that the only solution is x equals, or actually it was x equals negative 9, excuse me. X equals negative 9. It was x equals negative 9, right? Okay, so the other type of equation is a radical equation, right? We want to know how to solve a radical equation. These, I mean, obviously, like I said, and I'm going to keep saying it, and of course, the fundamentals always build up to calculus, right? This is a radical equation. So this one, the way that this one is done, you're going to go ahead and first subtract 1 on both sides, and then you have 2x minus 1 equals negative square root of 2 minus x. You go ahead and square both sides, excuse me, and then you have, so it's 2x minus 1 quantity squared equals 2 minus x. Now, you can use the FOIL method to multiply this out. So you have 4x squared minus 2x minus 2x plus 1, 4x squared minus 4x plus 1. So it's 4x squared minus 4x plus 1 equals 2 minus x. Now you go ahead and set this equal to 0. So you have minus 2 plus x minus 2, or you can say plus x minus 2 as well. So you have 4x squared plus 3x, or minus 3x, excuse me, minus 1 equals 0. You solve it using the Xbox method, so you get a negative 4 and then negative 3. And then two numbers that multiply to negative 4 and add to negative 3 are negative 4 and 1. So then it would be 4x squared, and then it's negative 4x, negative x, or x rather, and then negative 1. So it'd be 2x, or actually it would be 4x and x, and then it would be 1 and x, and then you would say 4x and negative 1. So then it would be 4x plus 1 times x minus 1 equals 0. So then that means 4x plus 1 equals 0, and x minus 1 equals 0. So then you would solve this one by subtracting 1 on both sides. You get 4x equals negative 1. You divide by 4, you get x equals negative 1/4. And then you just add 1 to both sides for this one. You get x equals 1. Now you want to check your solutions for this one. So you have 2x equals 1 minus the square root of 2 minus x. You're going to check x equals 1/4 first, or negative 1/4 equals, is that equal to 1 minus 2 times, or 1 minus the square root of 2 minus negative 1/4. So you have negative 2/4, and that is negative 1/2, equals 1 minus the square root of 2 plus 1/4, and then you have negative 1/2 equals 1 minus the square root of, and the way that you would add these two, you would say 2 over 1 plus 1 over 4. You can use the cross multiplication method. So it'd be negative 1/2 equals 1 minus the square root of, it'd be 8 plus 1 over 4. And then this would be negative 1/2 equals 1 minus the square root of 9 over 4. So then this is equal to negative 1/2, which is equal to 1 minus this, the square root of 9 over the square root of 4. So then it would be negative 1/2 equals 1 minus 3 over 2. And then you would say negative 1/2 equals, and you can get the same denominator on top and bottom. You get 2 over 2 minus 3 over 2. This equals to negative 1/2 is equal to 2 minus 3 all over 2. Negative 1/2 equals negative 1 over 2. So yes, it's a solution. And then you check x equals 1. So you want to do x equals 1 to x equals 1 minus the square root of 2 minus x, right? X equals 1. So you do 2 times 1 equals 1 minus the square root of 2 minus 1. You get 2 equals 1 minus, and then you have the square root, and then 2 minus 1 is just 1. So you have 2 equals 1 minus 1. 2 equals 0, which is a false statement. So therefore, x equals 1 is the extraneous solution. So x equals 1 will not work. So therefore, the only solution to this radical equation is x equals negative 1/4. Okay. Okay, so this one, this is a, oh, let me just make sure that it's the right, okay, yes, okay. So this one is a 4th degree equation of quadratic type. This is very similar to, what is it called? To a quadratic function. Basically, you can use Xbox for this. You can say that this is 1 times 8 is 8, and then you do negative 8. So two numbers that multiply to 8 and add to negative 8 are, or actually, let me make sure. Okay, so it would be, we have, or actually, I'm joking. You can't use Xbox method for this, but you can do the quadratic formula. Now, the way that I would do this, I would put it in terms of u, but also say, so u is x to the fourth, right? Or actually, hold on. U equals x, and I'm going to try to make this in terms of x squared, right? So if I square both sides, I can say u squared equals x squared, right? So that means I'm going to have x squared quantity squared minus 8 times x squared plus 8 equals 0. That gives me u squared minus 8u plus 8 equals 0. I can use the quadratic formula to solve for u, right? Wait a minute. So if I want to make this in terms of u squared, I can say that u squared is x squared. That way I can say that, oh my goodness, it's so weird how they did it in this one. Basically, they made it, so they set u equal to x squared, right? And they said that because u equals x squared, now they can go ahead and say that, so we can rewrite it this way, so that way we have u, this is u, and then minus 8 times x squared, which is 8u plus 8 equals 0. That way we can solve it using the quadratic formula. So then we have 8 plus or minus the square root of 64 minus 32 all over 2. So then we have 8 plus or minus the square root of 32 all over 2. And then we would have 8 plus or minus the square root of 4 times 4 times 2, which is equal, and then all over 2, which is equal to 8 plus or minus the square root of 4 times the square root of 4 times the square root of 2 all over 2. And then it would be 8 plus or minus 2 times 2 times the square root of 2 all over 2. And then it would be 8 plus or minus 4 square root 2 over 2. We can factor out a 2 from this. 2 times 4 plus or minus 2 square root 2 all over 2. We cancel this out. We get 4 plus or minus 2 square root 2. So x equals 4 plus square root, or 4 plus 2 square root 2. And x equals 4 minus 2 square root 2. So this is kind of a quadratic in disguise, really. That's what I would call it. You can still use the quadratic formula for this. Oh, however, I forgot to do one thing. This isn't x, this is u, right? This is u. u equals 4 plus or minus 2 square root 2, right? So x squared equals 4 plus or minus 2 square root 2. Because remember, we said that u is equal to x squared, right? So we have to take the square root of both sides. We have, this gives us x equals plus or minus the square root of 4 plus or minus 2 square root 2, right? Now, since we have 2 plus or minus terms, right, we can split this as follows. X equals positive the square root of 4 plus 2 square root 2. X equals negative the square root of 4 plus 2 square root 2, right? And then x equals positive the square root of 4, it would be 4 minus 2 square root 2, and then x equals negative the square root of 4 minus 2 square root 2. So these would be your 4 answers for this. It's a tricky one. You have to be careful. Right? So this would be, these would be your 4 answers. Okay, now this one is interesting as well. It's the same thing we did for the last one, except it's a quadratic. I mean, you're gonna have to substitute, okay? So let's say that, okay, so let's try to make this a 2. So how do we make this a 2? We're gonna have to say, well, 1/6 x equals 2, right? Because we want to make this, we want to know what do we have to multiply by to make this a 2. So we do x over 6 equals 2. So that means that we have to do it times 12. And then this one, we have to do the same. Well, this one we have to make a first term, right? Make it a 1 term. That way we have a quadratic to solve for. So we have 1/3 equals 1. Or actually, hold on. X over 3 equals 1. And then that means that x equals 3. So to make this a 1, we have to cube it by 3. Now we can substitute for u, right? We can make u equal to x to the 1/6. And then we can make u equal to x to the 1/6, and then make also we can also make it equal to x to the 1/3. Actually, you know what? Okay. Oh, this one's complicated. Oh Lord. So notice that this has to be in terms of u, right? So that means that u has to equal x to the 1/6. I know that because obviously we want it in terms of u squared plus u minus 2, right? So u has to equal to x to the 1/6. Now, to make this in terms of u squared, so to make this in terms of u squared, we have to say that u quantity squared equals x to the 1/6 quantity squared. This means that u squared equals x to the 2/6 power, which is u squared equals x to the 1/3 power. Now look at how this looks very similar to this, right? So that means we're going to have the following. X to the 1/3 quantity squared plus x to the 1/6 minus 2 equals 0. Now, u is equal to x to the 1/6, so we have u squared plus u minus 2 equals 0, right? And then we solve for u. This is, so u 1 times negative 2 is negative 2, and then we have our b term, which is 1, and then it's it would be negative 1 and 2, so that means that u minus 1 times u plus 2 equals 0, u minus 1 equals 0, u plus 2 equals 0, so that means that u equals 1 and u equals negative 2, okay? And trust me guys, I feel like this has a lot to do with also trig equations, so that'll be later. But anyways, we have u equals 1 and u equals negative 2. So that means that because we have, so give me 1 second. So because u equals 1 and u equals negative 2, we can plug those in for this. So we get that 1 quantity squared is x to the 1/3. We get 1 equals x to the 1/3. Now, we can turn this into radical form. We can say that because x equals, or because this is of the form x to the m over n, that means we have the nth root of x to the m, so that's going to be that 1 equals the cubed root of x, right? So that means that if we cube both sides, x equals 1, right? And then we also have the following: negative 2 quantity squared equals x to the 1/3 power. So we can say that 4 equals x to the 1/3 power. That means that 4 equals the cubed root of x. So cubing both sides, we get that 64 equals x, right? So we can check both of them. We can say, so we can check to see if x equals 1 is a solution. So if you plug in 1 for x, we get 1 to the 1/3 plus 1 to the 1/6 minus 2 equals 0. Anything, when we have a 1 here, anything, like any power, it doesn't matter what number this is, it's always going to be 1. You have 1 plus 1 minus 2 equals 0. 2 minus 2 equals 0, so yes, it is a solution. And then 64 to the 1/3 plus 64 to the 1/6 minus 2 equals 0. We can try to solve for this by using cube roots, or roots times the sixth root of 64, and then minus 2 equals 0. So then if you use your calculator, obviously this is 4, and then the 6th root of 64, that's like, how much is that? That's 2. Minus 2 equals 0, so then we have 4 equals 0, which is a false statement. So our answer for this one is going to be x equals 1. Okay. That was a very hard one. Because it's a little tricky, because you have to know what to make u equal to, right? This is a little tricky, so you have to be careful. And you actually use u substitution a lot in calculus. So that's kind of why I chose u instead of w and how they did over here, because yeah, it's just so you can get accustomed to those. Okay, so absolute value equations, these are also important. Even though in calculus, you don't really do, I mean, you do use absolute value equations in calculus when you do, I believe it's when you do, not derivatives, because you cannot do derivatives of absolute value, but when you do integrals, you do use absolute value equations. And that is at the end of Cal 1, by the way. They would give you an absolute value equation, and then you would have to use it using, like, you would have to find the area under a curve of an absolute value equation using, like, geometry. So we have this, and then this would just be 2x minus 5 equals 3, or 2x minus 5 equals negative 3. So then you go ahead and add 5 on both sides here. You get 2x equals 8, and then add a 5 both sides here. You get 2x equals 2. So you get x equals 4, or x equals 1, and then you have to plug it back in, right? So you do 2 times 4 minus 5, is that equal to 3, right? This is 8 minus 5, is that equal to 3? So it's 3, the absolute value of 3 equals 3. Yes, it's a solution. 3 equals 3. And then you do the same thing for this one. You get 2, so the absolute value of 2 times negative 1 minus 5, is that equal to 3? You do negative 2 minus 5, right? And then you get the absolute value of negative 7 equals 3. So basically you have 7 equals 3, which is a false statement. So x equals negative 1 cannot be a solution. Or, oh, wait a minute, my bad. It was x equals 1. My bad. So it'd be 2 times 1 minus 5, and then you do 2 minus 5, absolute value, and then you get equal to 3, and then you do the absolute value negative 3 equals 3, so 3 equals 3. So yes, it's a solution. So your solutions would be x equals 4 and x equals 1, right? Okay, guys, so that concludes this section. I know I took longer than I wanted to. Yes, this was a really, really long section. Of course, I didn't want to make it almost 2 hours, but it ended up being 2 hours, or almost 2 hours, because, yes, I mean, this is a lot. The equations that we did in algebra are really, really, basically, this is everything that we did in algebra. And I tried to go as fast as I could, but also I want to make sure that I explain this very well. So with that being said, guys, I hope this video helps, and if you have any questions, please let me know. I can actually try to, and I'll put timestamps on each one of these, for whatever equation, or if you're looking for a certain section, I'll put timestamps. But, yeah, I mean, this section had a lot of equations and it was a lot of steps. So I do apologize if I took longer than I wanted to. I always try to go as fast as I can. But, at the same time, it's very important to kind of explain it very well. So in the next section, we are going to do arithmetic operations on complex numbers. We're going to review this very quickly. And then from there, that'll be, basically the next section is just complex numbers, a bunch of complex numbers. And then that's the next section. And so with that being said, guys, I hope this video helps. Please subscribe to my YouTube channel if you can. And please like, comment, and/or subscribe. And I will see you guys in the next video. Thank you so much for watching, guys. Bye-bye.